We've covered what supercomputers are here in this video, and they are indeed super. The fastest machines today are in the realm of petascale computing. That's more than a quadrillion computing operations per second. The most powerful computer in the world today is Summit, the supercomputer at Oak Ridge National Lab. It's followed closely by Lawrence Livermore's Sierra supercomputer. But even today's most powerful high-performance machines can't keep up with the demands of the increasingly complex simulations required for national security, precision medicine, climate research, and a host of other areas of basic science. So, what's next? Some computing experts have called improving computing performance on this huge scale the space race of this century. Because after petascale computing comes exascale computing. If petascale is a quadrillion calculations per second, exascale is a quintillion operations per second. That's 18 zeros in 1 second, 10 to the 18th. And by the way, that's why Exascale Day is on October 18th. Get it? It's a small word for an almost unimaginably big number. If we went back in time a quintillion seconds, that's about 32 billion years ago, 18 billion years before the Big Bang. A quintillion is about the number of neurons in 10 million human brains. And if you somehow linked the top 100 fastest and most powerful supercomputers in the world right now and had them all work together on a single problem, you still wouldn't reach the computing power of one exascale system. If we look back at the progress we've made in improving computing power, we've made these strides because we've been able to pack more and more computing power into smaller and smaller spaces. That improvement in power has been holding steady for many years, but we're starting to see it slow down. We can't get the transistors any smaller. And plus, moving data around within a computing system that large takes so much energy. Huge leaps in computing also require leaps in the accompanying infrastructure. Interdisciplinary innovation has resulted in improvements to the architecture, data storage and management, and the kinds of software that can run on these machines. This and much more is what has made exascale computing a reality. The nation's first exascale system, Aurora, is slated for arrival at Argonne National Lab in 2021, followed later that year by Frontier at Oak Ridge National Lab and El Capitan at Lawrence Livermore in 2022, projected to perform at more than 1.5 exaflops. That's 1.5 quintillion operations per second. But why do we need this huge leap in computing power? At a national lab like Lawrence Livermore, scientists rely on computer modeling and simulations to solve problems that are way beyond the scope of any human. And see, the universe is in 3D, and the ability to incorporate additional physics into 3D simulations and perform them regularly means that the information scientists get from these models will be closer than ever before to what happens in the real world. El Capitan will allow scientists and physicists to perform larger and higher resolution 3D simulations than ever before, and fast. Simulations that might take a week to perform on Sierra, Livermore's existing petascale computer, could be completed in a single workday on El Capitan. El Capitan's primary mission will be supporting America's national security missions, ensuring the safety, security, and effectiveness of the nation's nuclear stockpile in the absence of underground testing. Across the Department of Energy, exascale computing will help scientists answer some of the biggest and most fundamental questions humanity has. It will allow for faster, more detailed models in areas of basic science, such as predicting the effects of climate change, simulating how drug molecules interact with the body in order to create more effective medications, optimizing designs for 3D printing, studying earthquakes, or how the 100 billion neurons in the human brain connect and function. Throughout history, we've pushed the boundaries of humanity's ability to understand and ask questions of our universe. And exascale computing is simply the next step in better, faster science. And what's next? Beyond exascale computing, beyond the boundary of Moore's law, into the realm of fields like quantum computing, well, we can only imagine.